So what I'm trying to do here is to solve that problem, which is a four. I'm sorry. I'm gonna solve the 4.46. Okay, which was causing problems to some of you. Maybe not the first part, but yes, the second part. So this is what I'm gonna do here. So this is the 4.46 from the textbook that we are using. Okay, so pretty simple. The first thing is they ask you, okay, give me the reactions that are keeping this ladder in equilibrium. Therefore, they're asking me about NB and they're asking me about AX and about AY, which are these that are in the figure. Um, okay, so I'm gonna jump right into it. I'm gonna do force at x equals to 0, and this thing will give me minus AX plus something about MB, not the whole deal, but something. And I already have prepared, just to save some time, I already have prepared some of the triangles that I need to do. I can know from the stir that I have this triangle, and since this NB should be perpendicular to the stir, therefore you need to change something. That's a rule. You can actually try to prove it, but since we are trying to save some time, this is what I would have. It's actually the opposite from this triangle over here. So I'm gonna use this in order to know that the horizontal part is the 3 divided by 5 that I need equals to 0. Okay, so from here I still don't have any one of these, but I already have something about it. So forces at y, and you will get to a lot of stuff. So let's just put it. So minus the weight of the person minus the weight of the stir, and I will have something about NB, the vertical part, which is the one that I'm interested, and the plus AY equals to 0. So far, not known, not known, yes known, yes known. It's in data of the problem. I will put them here, and not known and not known. So you are kind of problem. So therefore, I'm still missing one of the equations, which is the moment. I'm gonna do moment regarding A equals to 0. So moment regarding A equals to 0 regarding this point here. What I will have is, maybe you can detect that since NB is actually perpendicular, I have that NB times 2, but in the negative part, you try to figure it out why. And I will have the W of the stairs times the distance, which I already have done my trigonometry here, try to prove that this thing is 2 meters. And the other thing that according to the first case, they are telling you, look, the distance that I have this guy on the stair is actually 1.5 meters, okay? So if I do that, and you have some eye on it, you will see that 1.5 is actually around here. This is 1.6. So around here should be located the person in the stairs. For the first case, I don't want to put it. This is how the general drawing is put in the book, but since you have some idea of about the distances, therefore, for your case A, for your example A, you have the person right here at 1.5. That's data of the first case problem. Okay, so 1.5. Therefore, since I just need to move myself from here to there, so I'm gonna put the weight of the person 1.5. So I'm gonna put the 1.5, and then I need to decide the sign. Maybe you agree with me that this thing is positive and this guy is positive. Since no other force is producing moment regarding A, I'm gonna try to get it. So I actually can get the NB right away. See, and this thing will be, I'm gonna put the numbers so you know what I was doing. So it's gonna be 20 times 9.81 times 2, that's the weight of the stairs, times 2, plus the weight of the person, 90, that actually is the mass, 90 times 9.81 times 1.5, divided everything by 2 according to this formula. Therefore, if you do the math, and if I'm not wrong, this thing is actually goes to, God, what do I have it? It's 858, because I already had done it in a piece of paper. So that I was trying to do. 8.58, 37, so newtons. So I already have that thing over there, and with that information, I can get the other stuff. So from here, so I'm gonna go here, and now from this equation, I can get AX, which is equal, I'm not going to do the whole deal, but you try to get to the same place, 0.25 newtons. Therefore, this is pretty straightforward. There you got it. And now, since I already have this MB from here, therefore I'm gonna get AY because all these guys are known. And if I'm not doing anything wrong, AY should be 39, 392.4 newtons. I have it over there. So I have finished the case A problem. In the book, what they are giving you is the reaction at A, which should be, okay, maybe you get it, AA squared, AY squared, and this is actually, according to the book, to around 647. So you can check that out, and we are agreeing with what the book is saying in the answer section. Okay, so good. Now I'm gonna go, ooh, what a line here. I'm gonna try to do the case B. The case B is telling me, look, now you need to find out where the person should be located in the stair where these things would fall. Okay, so where the stair, I'm gonna try to do my best not to do some lousy drawing here, but you have the, let's just put the thing NB over here, and you have the A over there. There is still the weight of the stair located right there, but now the weight of the person has changed position. And now they are putting around here, but you actually don't know this distance. They are actually telling you, hey, buddy, why don't you give me this distance over here if this thing falls, okay? So what I tried to do here was to get this problem. I'm gonna think, this is the way that you solve it, but I'm gonna think that here at A, only AX is acting, only AX. This AY is gone, it's actually equals to 0. Why? Because what I'm thinking is the situation where this ladder will try to turn around like this. So there is no holding here. There is holding at the vertical wall. That's why I will keep the AX, because of this person has just moved up in the stairs, and maybe it's gonna try to fall. So what I'm trying to get here is the moment regarding B equals to 0. That's what I will try to get. So without this holding at the vertical part of A, okay? So I don't know if you see it, but therefore I will have AX as an unknown. I will have NB as an unknown. They are unknowns because it's not the last case. And now X as an unknown, which are the thing that they're asking you to get. Okay, so what I will try to do here is, apply the equations. I already have them over here, so I don't want to do something that is done in the wrong way. But let me just go ahead and put it over there. So yeah, let me just get AF. Sum of forces regarding X equals to 0. Then I will have the NB, something of NB, but it's still the same triangle. So I'm going to use 3 divided by 5 and minus AX equals to 0. So I don't know. I don't know this guy and I don't know this guy. I'm going to go to Y part. The Y part would be equals to, let me just put again the weight of the person. So minus the weight of the person minus the weight of the stairs. There is no AY, okay, so I cannot put that, but there is the vertical part of the NB. So I'm gonna put 4/5 equals to 0 going up. Therefore, from this one is the only unknown, and I can actually get it right away. So NB equals to, let me just put the numbers so nobody's out of this stuff. So 20, well, I actually can put the common factor, but let me just do this stuff. So 20 times 9.81, which is a G, plus 90, the mass of the person, 9.81. Okay, so I'm trying to get the weight. And what else? What else? Is that it? But now I will try to multiply this by everything. I should say everything is multiplied by 5 divided by 4 because I passed this guy to the other way. Okay, to the other side of the equation. Therefore, MB, according to me, you try to check it, is 1348.87 newtons. Okay, so new normal. This is a new value of the normal. Now with that, I actually can get now from there AX. So let me just put it over here. I think I can finish right here. So from here, I can get now that AX equals to a new value, which is 809.3 newtons. So that's what I'm getting over there. Now what I will try to do is this one over here. So if I do this one over here, because I already used two equations, now I have to use another equation, which is moment, again, regarding B equals to 0. That's actually the situation that they are asking you to solve, okay? So let me just try to put it over here up. So what I will try to write over here is this thing, which is, okay, so let's go. Regarding B. So regarding B, I don't know if you see it, but I have this thing, which is 1.2 going down to find this AX over here. I need to go from here to there, from here to there. This thing was, I don't know if you follow me, but it was 1.6 from the start. This was located at 2, okay? And this guy is located at X. Okay, so what I'm gonna do is this. Let me just put the weight of the person. The weight of the person times a distance, which could be X, yeah, from this vertical wall, but I'm actually measuring from here. So what I'm gonna do is X minus 1.6. So I'm gonna go 1.6 here and then go back X, okay? But I'm thinking that X is higher than 1.6, so that's what I would have. I'm thinking that I will have the weight at my left of point B. Therefore, it will produce a moment in the positive sense. So plus. Now, I'm thinking I'm writing this right. So plus W of the stairs. Now, how much should I walk myself from here to there? I don't know if you see, but this, the distance, the separation from here to there is actually, I'm gonna try to put it here, is 0.4. Maybe you can get it with the 2 and the 1.6. So this guy is actually 0.4, okay? There's still one thing missing, which is the AX. So these two guys here are positive. One of those guys should be compensating that. Thank God I have the AX, so I will put the AX times 1.2, which is the distance that I have to walk down to find this guy perpendicularly, and this guy is a minus, so, and this guy is equal to 0. If you do your algebra right, you will get that X 1.6 should be equals to all these guys to the other way, AX 1.2 minus WE 0.4, and everything's gonna be divided by the weight of the person. So if you do this thing right, you should get to this point, 2.61 that I had. So try to do it slowly and you will get there. This is not an easy example because you don't know the actual conditions. You just say, well, the stair might fall or it should be falling. What does that mean? Because you can actually say, well, something is happening at A, but maybe it's actually happening at the weight, or maybe it's something happening at the weight of the guy or something. But this is the situation that I need to do. I needed to do this, to cancel this AY over there, because it's no longer holding it. It cannot pull, the floor cannot pull. So this guy is just gonna move that way, okay? So the only supports are the step, which is the NB, okay? The normal for that stair corner, and AX that is actually going over there. So try to do and see yours, and let's see you later, okay? So see you guys.